In this video, let's continue our discussion in numerical solution of first order ODE, where we are going to discuss how to solve single ODE using fourth order Ranskata method. The most popular Ranskata method is often referred to as fourth order Ranskata, or we call it as RK4. It was developed around 1900 by the German mathematicians C. Ranch and M. W. Kata. RK4 is normally known as classical fourth order RK method. So, for the formula for RK4, the next value for y xi plus 1 is determined by the sum of the current value of y xi and the weighted average of 4 increments. So, the term case represent K1, increment of the slope at the beginning of the interval using y. K2, increment of the slope at the midpoint of the interval for K1, while K3, increment of the slope at the midpoint of the interval using K2. And lastly, K4 is the increment of the slope at the end of the interval using K3. So, here is the formula for fourth order Ranskata method. So, we have xi plus 1 is equal to xi plus h. And how to calculate y? Yi plus 1 is equal to yi plus h over 6 multiplied with k1 plus 2 k2 plus 2 k3 plus k4. And here we have k1, k2, k3, k4. So how to find the value for this k? So this is the formula. Okay, k1 is equal to fxi yi, while k2 is equal to fxi plus half h yi plus half k1h. K3 is equal to fxi plus half h yi plus half k2h, and K4 is equal to fxi plus h y plus k3h. So now let's try one example. Use RK4 method to approximate the solution of the following ODE. So this is our differential equation. dy dx is equal to exponent minus x minus 2y. And the initial condition given when x0, y is equal to 2. For the interval, x starts from 0 until 2 by using RK4. Given also our step size h is equal to 0.5. So, our differential equation will be our fxy. And if we sketch our number line, so we will have x0 equal to 0, step size 0.5, that means x1 equal to 0.5, x2 is equal to 1, x3 is equal to 1.5, and x4 is equal to 2. So, when x0, our y0 is equal to 2. So the thing that we are going to find is y1, y2, y3, and also y4. So this is the formula for RK4. We have xi plus 1 is equal to xi plus h. And yi plus 1 is equal to yi plus h over 6 multiply with k1 plus 2 k2 plus 2 k3 plus k4, where our k1 is equal to f xi, yi, and yi. And then k2 is equal to f xi plus half h, while yi plus half k1h. For k3, f xi plus half h and yi plus half k2h. And lastly, for k4 is f xi plus h and yi plus k3h. Okay, let's start our calculation. Okay, we start with I equal to 0. When I equal to 0, we have x1 is equal to x0 plus h. That means 0 plus 0.5. So we will have 0.5. So here, when x1 equal to 0.5, we are going to find the value for y1. Okay, so this is the value for y1. So before we can get the y1, let's calculate our k2. So we start with k1. K1 is equal to f x naught y naught. So substitute the value f x naught equal to 0, y naught equal to 2. So we substitute this value into our function f. So this is function f. Okay, we substitute the value. So our k1 is equal to 3. Oh, sorry, minus 3. So I continue the calculation with k2. K2 is equal to f x naught plus half h and y naught plus half k1h. So I substitute all the value. So I will have f 0.25 and 1.25. So I substitute this value into our function f. So I have k2 is equal to negative 1.721. Then how about k3? K3 is equal to f x naught plus half h y naught plus half k2h. So substitute of the value, so I will have f 0.25 and also 1.5697. So substitute into our differential equation. So our k3, okay, k3 is equal to negative 2.3606. Okay, now let's calculate our k4. So formula for k4, f x naught plus h and y naught plus k3h. So substitute the value, I will have f 0.5, 0.8197. So from here, I will have k4 is equal to minus 1.0329. So from here, okay, I just substitute into the formula for y. y1 is equal to y naught plus h over 6, k1 plus 2k2 plus 2k3 plus k4. So I will have my y1 is equal to 0.983. So now we continue. So we already have our y1. So now we are going to find y2. y2 is when I is equal to 1. So we start over again. We calculate k1, k2, k3, and k4. So that I will have my y2. y2 is equal to 0.5106. Then when I is equal to 2, so I will have, okay, so we are going to calculate again our K1, K2, K3, K4. Then we will have our Y3 is equal to 0.27, 0.2774. And lastly, when I equal to 3, again, calculate your K1, K2, K3, and K4. Then you can get the value for y4 is equal to 0.1562. Now, let's solving one application problem. So this is the problem. The open loop for the speed W to a voltage input of 20 volt is 0.2 dW dt is equal to 10 minus 0.6 W, where T is a time measured in hour. If the initial speed is 0, calculate the speed at t equal to 1 with a step size 0.5 by using RK4. Okay, so firstly, let's let's list all the information that we have. So this is our equation 0.2 dW dt equal to 10 minus 0.6 W. Firstly, let's rearrange our equation. Make sure our equation coefficient for our derivative must be 1. So dW dt is equal to 10 minus 0.6 W divided by 0.2. So I will have dW dt is equal to 50 minus 3W. So this function is our f, dW. This is the initial condition for the function. When t equal to 0, the speed w is equal to 0. And this is my timeline. So t equal to 0, t not equal to 0. So the step size is 0.5. That means t1 is equal to 0.5 and t2 is equal to 1. So we are going to find what is our t equal to 1. So from here, when t0, our w0 is equal to 0. So we are going to find the value for w1 and also w2. Okay, let's start the calculation. So the first calculation, I is equal to 0. So when I equal to 0, ti plus 1 is equal to ti plus h. That means t1 is equal to t naught plus h. So t1 is equal to 0 plus 0.5. So we have t1 is equal to 0.5. So before we can get the value for w1, so we need to start to calculate our k1, k2, k3, and k4. So k1 is equal to f t naught w naught, where t naught is equal to 0 and w naught is equal to 0. So substitute into our function f. So we have k1 is equal to 50. Then we go to k2. Formula for k2, f t naught plus half h and w naught plus half k1h. So we substitute the value. So we have f 0.25 and 12.5. Substitute into our function f. So we have k2 is equal to 12.5. So how about our k3? What is the formula for k3? K3 is f t naught plus half h, w naught plus half k2h. So we substitute the value. We have f 0.25 and 3.125. Just use the value into our function f. So our k3 is equal to 40.625. And lastly, we are going to find our k4. k4 is equal to f t naught plus h and w naught plus k3h. Substitute the value. I have f 0.5 and 20.3125. And we use the value into our function. So k4 is equal to minus 10.9375. So after we have our k1, k2, k3, and k4, so we can calculate our w1. w1 is equal to w0 plus h over 6, k1 plus 2, k2 plus 2, k3 plus k4. So we just substitute everything into the formula. So from here we will have W1 is equal to 12.1094. Okay, how about W2? So W2 we need to repeat, okay, the same process as before, but our I is equal to 1. When I equal to 1, so we have T2 is equal to 1. So we start with our K1, our K2, K3, and K4. Start it again. So from here, I will have K1 is equal to 13.6718. K2 is equal to 3.4175. K3 is equal to 11.1086. And K4 is equal to minus 2.9911. Then I substitute into the formula. So I have my W2 is equal to 15.4 15.420